we're going to hear from another instructor, from Dr. Ghada Nehmeh from Bronx High School of Science. She's going to talk briefly about the courses that she developed. And Ghada is a graduate of our PhD program in science education at the Institute for STEM Education, along with just about everybody at this table right here. So Ghada, thank you so much for joining us today.
Well, thank you, Angela. Okay, so what's physics? This is a question that I always, or any other physics teacher, like to ask their students at the beginning, at the end of the year. For my student, when I start this question, they always remember Newton's, remember the apple falling on his head, and that's what they know about physics. At the end of the year, like as you're saying, I would love my student to just say, when I ask them what's physics, at least to say it's everything, the science of everything, or the science to think critically. However, you know that as a Regents physics teacher, that's when I started, we teach a lot toward the test. We teach a lot of physics, and at the end of the year only, we can start looking at modern physics, for example, and all what we do, probably you all saw this, we all saw this reference table where we teach them about photons or about about quarks. We just talk about this page. We teach them how to apply it. Very quick and just to be able to pass the exam. So when you ask them what's physics or what they remember, we ended up teaching them, they say, oh, that's a projectile motion, it's an inclined plane. So that's what they remember from their physics classes. When it's time to go to higher level courses, again, as a physics teacher of AP Physics with calculus, all what we can teach them, we have mechanics and electricity and magnetism. Those courses are equivalent to university physics semester 1 and semester 2. But we also teach mechanics and we teach electricity and magnetism, and we don't go above and beyond. For the same reason that we have to have a test at the end of the year, and we have to do it as quick as possible. In 2013, I had 20 students. They were very advanced students, and they already did all their calculus classes, and they were in my they were juniors at that time. They asked what we're gonna do next. They wanted another physics class, and at that time, was a course actually created by the students. I told them I can do modern physics class where I can teach, because I loved quantum a lot in college and in graduate school, we can do quantum and we can do theory of special relativity. But I don't have a curriculum for that. So we are going to do it together. I can teach as much as you can take. And we'll do it throughout the year together. And they loved it. The administration loved the course, and we started that course. And then I took that course, and I just looked at about modern physics, introductory physics classes in college, and I just endorsed those curriculums, and I did it because those students, they know calculus. They finished AP Physics with calculus. They are advanced students. So I did it with all the math they needed. At that time, after a few years, the College Board decided to start to split AP Physics B into 2 courses, which is AP1 and AP2, and so no more juniors in AP Physics C. So that would kill my course. So what to do at that point? So we decided to change that course, to change that course and to slow it down, and we decided to do it algebra-based. To do that course algebra-based, we stopped focusing a lot on math, and we started looking at it from historical lens. And so where we set up the historical context and we present the experiment and observation results, we encourage students to grapple with the consequences and resolve issues themselves. We try to use project-based curriculum. All their assessment were project-based, so they don't feel very intimidated with the complexity of it, and we encourage them to explore and beyond standard material within their projects. Instead of emphasizing the math at that level, because now they don't have the calculus part, we start emphasizing conceptual understanding, such as and we talked about qualitative behavior of wave functions instead of based on Schrodinger equation instead of the mathematical one. And we spent more time with spins and superposition, because with that you need more, it doesn't need more advanced math. And we started gradually increment the math that we needed. They loved, for example, complex number when they saw it from, even though they learn about this in pre-calc, but when they saw it with superposition, they loved it a lot, and they can see math now as in application in quantum physics. And then now, with another teacher now doing the course, because I grabbed another course, we are not focusing a lot on calculus. We are doing, as I said, algebra based, but we're talking about all the concepts that we were talking about in the previous course. And now it is based, the challenge always is gonna be the experiments, which labs we need to do. So we were actually doing a lot of simulations and a lot of thought experiment, because the first semester of the course is the theory of special relativity. The second semester of the course, when we go into quantum physics and the quantum mechanics, we do Schrodinger equations, but we stopped at the hydrogen atom, and we do a lot of superposition principle entanglement, and the students actually were able to get them. They liked the course. And a lot of our students, if you look at their work, we make it, as I said, project-based, so they do not need to actually do all the math if they can't. So we were starting with the student, and we are ending the class with whatever they can do. One of my students, Sebastian Perez, who took the course and who went to MIT, graduated with math and working in the field now, he sent me this note saying that the modern physics class offers students a unique opportunity to evolve their understanding of the world. The quantum framework promotes thinking probabilistically and interrogating what a state truly means. These are ways of thinking not only useful in physics, but in mathematics, engineering, programming, or design. Giving students exposure to this earlier in their journeys starts building connections that pays off down the line. They loved the course. They said it had them in college and after that to build on it. It also, we have a lot of community supports now that's trying to help us promoting those types of courses, such as the Step Up, which is a movement that they're creating research-based lessons to introduce different careers to students that they can get out of physics. And one of those lessons, they are trying to get a lot of quantum science that physicists that they actually work in different fields. This is just one slide of many of different scientists that they work in the field, and they're doing it out of physics. So I'm just putting this as an example. So those lessons, they can help motivate students to actually pursue physics and to actually go into quantum physics at that. Thank you.
Thank you, Ghada. Are there any questions for Ghada?
Ghada, 2 of my grandchildren have taken that course, and I can just endorse what she's saying. One of them has chosen to major in physics, and one of them chose to major in statistics. And this course was one of the classes that they spoke to me about, that they were so excited that it changed their worldview. So if this is something that you can introduce in your schools, realize that it will be a magnet for students that you don't think exists, and it will open pathways. When my granddaughter told me she was going to major in physics, I said, why? And she said, because of this course.
Oh, thank you.
So just an FYI.